Good afternoon, everyone. I'd like to welcome you to the March webinar for the Lake States Fire Science Consortium. I'm Jack McGonstinsky, and I'm the Program Manager for this consortium. I'll be moderating the webinar this afternoon. For those who may be joining us for the first time, let me give you a little background. We are funded by the Joint Fire Science Program and are one of 15 regional consortia, or fire science exchanges, across the country. Our mission is to accelerate the awareness, understanding, adoption, and sharing of wildland fire science information by federal, tribal, state, local, and private stakeholders across the Lake States and the adjacent Canadian provinces of Ontario and Manitoba. We strive to be inclusive and neutral science partners working to foster collaboration among researchers and practitioners and organizations and individuals, and by developing innovative approaches to science delivery while facilitating dialogue about new science findings and emerging needs. Before we get started, let's take a few seconds and look at our webinar interface using Adobe Connect. If you'd like to ask a question or interact with the attendees, please use the chat box located in the lower right-hand portion of your screen. Once you type your question, make sure you click the send button. We'll be monitoring these questions, and we'll make sure that there's an opportunity to address them. If you would like to learn more about the consortium and what we are doing, please visit our website at lakestatesfiresci.net. Please also sign up to receive our newsletters and announcements of our activities, and you can also follow us on Twitter and Facebook. Now on to today's webinar. Brian Stearns has worked with the Forest Service since 1997. In 2001, he accepted the position as a fire dozer operator. In 2004, he started a fire monitoring program for the Huron Shores Ranger Station. In 2010, he accepted the duties of being the assistant leader on the Huron Manistee Wildland Fire Module, and from 2012 to the present has worked as a module leader. So with that, Brian, the show is yours.
Thank you. Thanks everybody for being on the webinar today. I'm going to be talking about some monitoring that we've done on some landscape level prescribed burning, primarily in red pine and jack pine ecosystems. So the title, just a little bit of background about the project. The projects that we're going to be covering primarily today go by the title of Brittle and Memorable, and we've kind of combined them together because they're adjacent to each other. These projects are landscape level reintroductions of fire into, like I said, primarily red pine and jack pine dominated ecosystems. The goal of the projects are to improve firefighter and public safety, reduce fuel loading, and restore fire adapted ecosystems. We started these projects back in about 2004, and one aspect that I guess I'm kind of proud of is that I've kind of worked this project kind of from the ground up. I was the primary writer editor for the environmental assessment for this, so I did all the NEPA work for it, and then I've done a majority of the implementation on the project too, including all the monitoring that we're going to be looking at today. You can see the project's located in the kind of northeast corner of the Lower Peninsula of Michigan, where it's maybe 10, 15 miles outside of Oscoda, Michigan, right in the middle of the Huron. The landscape level projects comprise about 14,500, well, close to 15,000 acres. And then we also have some adjacent projects even to this that have popped up over the years. All in all, there's probably 16 to 18,000 acres of continuous prescribed burning across this landscape now. This project sits atop sandy outwash plains, so the soils are xeric, they're well drained. You can tell when you look at the trees that they're kind of emaciated due to the poor soil, and they tend to burn very readily. Annually, the area receives 28 to 29 inches of rain, or precip I should say, because a lot of that's snow. The surface fuels comprised of a lot of Carex pennsylvanica, a lot of cool season grasses like little blue stem. The main shrub component would be a low stem or a low bush and a high bush blueberry. We do have a lot of little pockets of warm season grasses and prairies that, as this project goes on, seem to be taking hold. That is one of the markers that we're looking at is trying to get some of those warm season grasses back into these areas. The measurements that we conducted on this project consist of measuring fuel loading both pre and post burn. The litter and duff, we took depths and we did the tonnage for those. We measured fire severity, surface fire behavior potential. We monitored with photo series. We worked with our wildlife and timber folks to kind of come up with some ideas on mortality and snag creation. They had some interest in figuring out what we were creating for snags with this burn program. We looked at crown scorch, bull char, and now we're looking at char depths. That's something that we're looking at here in the last couple of years. Crown bulk density, soil. We're measuring carbon component with Michigan State University. We're taking samples out here and sending those off to MSU so they can measure the carbon that we're producing. We're doing vegetation mapping, fire behavior, smoke, and also now we're doing needle density. We're part of a program with Matt Jolly measuring needle density in our Memorable project. So our plots, the schedule that we have developed for these plots, we take all of our plots that we have across the whole zone and we come up with a schedule based on a pre-burn measurement, a post-burn that we try to do within a year. Usually we get in there within a month or two, but we're supposed to get in there within a year. And then we do a follow-up at 3 to 5 years, depending on the protocols. We put all this stuff into a spreadsheet, and you can see there's a little kind of excerpt from the spreadsheet right there. We also have a couple more columns that I didn't put in here, but we assign those to different modules every year, and they're responsible to make sure that those measurements get conducted. And then this map down here, you can see that's our existing plots that we have for the program right now. There's some yellow ones that you might notice over on the right side over in the Memorable area, and those are the old control plots that we've continued on with the current monitoring. And then in addition to those, this year there should be 4 more of these kind of square mile units that will receive their first entry pre-measurement plots for this year. For our monitoring, we came up with protocols based on the Park Service's handbook for monitoring and the basic Brown's transects. And what we did is we put together a 6-page booklet specifically for this monitoring program, so we can send that out with some folks, and it should answer a majority of their questions on what to bring out with them, what distances, what materials they're measuring for, all that kind of stuff. And it goes into photo plots, how to archive it, all that information. And that has drastically cut down on some of the variables that we used to get by providing this document for folks to go out with. And it also alleviates a lot of the questions like, do we count pine cones or stumps or those kinds of things. So that's been a big advantage to getting this program going is having that protocol sheet for us. The data that we are collecting, I mean, I talked about the aspects of it, but once we collect it, we're putting it into 2 major forms. One of them is the fuels calculation, which currently we're using a spreadsheet, a pretty extensive spreadsheet that is very transparent with how the numbers are calculated, and we bring tablets out to the field with us, and we just enter them right into the spreadsheet on site, and with the idea that by not doing it on paper and then bringing it back and re-entering it into the computer again, it kind of takes out that one step, making it a little more efficient and hopefully reduces the chance of error. So you can see up in that upper left corner, the spreadsheet. That's kind of the product portion of the spreadsheet that we have. And then below it is kind of a little clip of our mortality spreadsheet that we developed. And those are the components that we're measuring for our mortality. Like I mentioned, we had gotten together with some of the other disciplines and talked about, as long as we're going out to do measurements, what can we do to help them out. So wildlife wanted to know about whether or not there were cavities in snags. Timber wanted to know about insect activity. So some of those things we included on this mortality sheet that you might not see in other places, but that's just to kind of help out some of those other shops as long as we're going out and doing the measurements. The burn day data that we're collecting is all the normal stuff that most folks are collecting already. And then what we've done is, there again, throwing it into a spreadsheet, and it just kind of gives us a quick reference as to the parameters for that day, so we can start tracking trends. And then if we want more detail, we can go back and look at the actual sheet from that particular burn. We also took all of those burns and we kind of color coded them with a gray for maybe less than desirable fire behavior, a green for a fire behavior that met our objectives, and then a red for high-end fire that exceeded the proposed fire behavior. So there again, that just kind of helps us to be able to track trends, and we were able to use this to kind of dial in our days since last rain parameter that we figured out after I think we had about a 20-acre crown fire within one of our prescribed burns that kind of crawled up the boles of the trees one night. It was a night burn, and crawled up the boles of the trees and kind of made a little run. That's when we really started keying into things like days since last rain. There again, that's a little clipping from that spreadsheet that we maintain there. We also perform photo plots, which oftentimes speak volumes, just being able to look at before and after pictures. So a lot of these we figured out over the years to come up with parameters, because when we started looking back at some of the photo plots, they seem to be at different heights above the center pin for that plot. Some of them were angled more towards the sky, or some more towards the ground. So coming up with more stringent protocols for that has helped us in the last few years. So some of the photo plots here, you can kind of see, this would be from Memorable here on the left. Pre-burn, this would be back in 2004. And this photo here on the right beside it is from 2011. You can just kind of see that there's little piles of slash out through here that are gone now. This red pine here is now a snag. And then the canopy base height in this one, it's low. There's a lot of oak brush. Here you can see out to the road, which is probably, it's over a quarter mile out to the road, but you can see the light coming in from the road there off in the distance. So those tend to be dramatic representations that a lot of people can key into, even if they're not into, how many tons per acre you've taken off a burn unit. Then down here, there's an example of front, looks like Brittle 10, pre-burn, lots of needle cast there. That's a post-burn, probably 3 years, just prior to a second entry here. So this would be post-burn second entry, looks like 2014. So there again, you can especially with the needle cast here, you can really see how much was kind of taken off the surface there. Here's just some of the highlights from some of the results that we're gleaming from this stuff. This little graph here came off from Memorable North, which is the very first unit that we started burning in this project. And you can see the total here starts out at about 16 tons per acre. After the first burn, jumps down to around 7 tons. And then after 5 years, it's back up around 13-ish. The second burn entry brings it back down to close to 8, and then it's kind of plateaued off since then. In one of the things that, which is well documented, but down here with these heavies, you can see where we slicked off a little bit with the first burn, and then they slowly start ramping up, and as that middle story, you know, has had some mortality, we're cleaning out some of that mid-story, that's starting to fall over and accumulate a little bit, and we pick it up with later burns. The big component, of course, is our litter and duff. And in this graph, they're kind of combined, both litter and duff in tons per acre, and they're following just the basic trend. Down here you can see with our tons per acre that the duff really does, the duff doesn't seem to be consumed quite as much as the litter, and the litter makes up a majority of what we're taking off with each burn entry. So, which is good. We want to maintain some of that duff for cover for erosion purposes because we have these really sandy soils, but that needle cast is one of the main carriers. So cleaning that up every 5 to 7 years seems to kind of follow what we're reading as far as keeping fire behavior kind of at more of a moderate pace. And then up here, you can see this is the depth. So this is pre-burn down here. You've got litter pre-burn and post-burn. So that's there again. That's where most of that tons per acre that's showing up on this graph is coming from litter consumption. Here's a few more tidbits, just some general kind of things that a lot of people will ask questions about the project. They'll usually want to know like how much jack pine the project, you know, that's found within the project, and this would be like significant stands of jack pine where it's either all jack pine or majority of the trees are jack pine. So we're looking at about 1,400 acres that we've burnt so far. The largest continuous stand of jack pine that we burnt is 246 acres. And that stand, it was pretty homogeneous. I would say probably 12 foot tall, and the canopy ran almost all the way to the ground. We were able to underburn that a couple times now, so, and it's done pretty well. We don't have a ton of white pine as far as just nice homogeneous stands of white pine. There's only about 26 acres of that. As far as aspen goes, 252 acres of that, the largest stand being 52 acres. And then oak, which most of it is northern pin oak within this burn unit, but you're looking at about 300 acres of just oak. Most oak is, like jack pine, is found throughout the whole project area, mixed with the red pine. But as far as, you know, kind of majority of it being oak stands, you're looking at 300 acres, with the largest stand being 120 acres. And then this graph over here on the right shows the canopy base height, which for as far as providing for that firefighter and public safety, meeting that objective, I think this is an important factor. And we've shown that we've been able to raise that canopy base height from an average of, you know, 12 feet up to 24 feet. So that there again, that inhibits fire's ability to initiate a crown fire. So that's an important factor that we've measured. Also, these numbers I just crunched here in the last couple days, but our average crown scorch per entry is about 11. We're getting about 11% of the crown that we're browning up. Our average DBH is right around 11 inches, and it looks like our average tree height is 40 feet. Bole char seems to be in the last couple of years, it's come up on this forest numerous times, and then I've had requests for some information at a couple other forests. So we started honing in on this a little more, and that's why we're working with Dr. Meisel from MSU and giving her data on char depths that's within the bowl. And then we've always been measuring our bowl char, the heights, both the maximum and minimum. So there on the left, you can kind of see a 1 year post-burn red pine up on top, and then the one below it is 7 years. And that's what we're kind of finding is right around 7 to 9 years is when that tree has sloughed off enough of that outer bark that, you know, the remnants of that burn are not really noticed anymore. And then that graph just shows the height in feet, starting with 1 to 2 years, not really much difference, but then decreasing 5 and 7 years, you can see how that's slowly coming down, sloughing off the tree. The depths that we're looking at about 3 feet high. Originally, when we measured this, because we were working for MSU, everything was done in meters and millimeters, so all this has been converted over. So that's why it's kind of in tenths of inches. But you can see there you got 9/100 of an inch and 1/10 of an inch at 1.5 feet. So moving on to, this would be our mortality. So this is taken out of the memorable units there again, because that's some of the oldest data that we have. We have a lot of this stuff for all the units that we've burnt so far, but this one, to me, kind of best represents everything we see across the landscape so far. So there you can kind of see measurements done in 2005, 2010, and 2013, and then Memorable North gets measured again this year. And we might even try to get another burn entry. We're looking at maybe doing a summer burn for Memorable North this year, so hopefully we'll have even more information by next season. But here you can kind of see that pre-burn mortality across that unit was right around 5.3%, and then post-burn it jumped up to around 9.5%. So that includes that little 20-acre crown fire run that we experienced in Memorable North. So overall, you know, even with that 20-acre crown run, we're still only looking at 3.5 to 4.5% mortality from the burn. And then after it kind of plateaued, it was right around 0.5% for mortality. And that's what we tend to find across most of our burn units is that 0.5 to maybe 3%. And then Memorable South there, again, kind of the same numbers. One thing about this project was in the NEPA, it suggested that we should be looking at about 9 snags per acre to meet habitat for woodpeckers. And so within these units, we've been able to get that. We've actually gone out and wildlife has topped some of the trees to help kind of create some of those snags because we weren't quite getting enough just with the prescribed burning. And that seemed to get us to about that desired level. But we found that when we burn under these low to moderate conditions, we're not creating enough snags to meet that need for woodpeckers. So, but we're hoping as we get this landscape kind of conditioned and it is able to take more fire, we might be able to, in some areas, kind of horse that through there and create more snags. On Memorable South, last time we burnt it, we sent head fire across probably a quarter of the unit just because it was a barrens area that had been mechanically created, and we had black on the downwind side, and everything was kind of lining up, and we just zipped off about 150 to 200 acres with just head fire. So that was kind of a cool event, and we still only got that 3.4% mortality by doing that. Another thing we've been doing is entering all of our data into the fuels characteristic classification system, FCCS, and this is pretty comprehensive system to catalog all of your vegetation. Here I give an example of the cover page where you enter in your overstory, midstory, and understory, but then you can also enter in your snags, all your shrub components, your non-woody fuels, any accumulations of woody fuels if you have slash pockets, lichen and moss, and then your litter and duff. All that stuff gets entered into this, and then it sends out some pretty cool information with that, with all those entries. It calculates the surface fire behavior potential, which we'll get into on another slide. Gives out like a behave run of sorts that you can tailor to meet different criteria. The general data that it gives out just kind of stratifies by all those components. So you get a tons per acre for just your overstory, you get tons per acre for mid and understory. All those different criteria, it calculates the different fuels for you. So if you want to hone in on how much was removed in any one of those strata, this is a cool system that you can use to quantify that with. It also takes into consideration things like needle drape. So if you've got long leaf needles that are dropping into, say, your blueberries, and that's affecting your fire behavior, you can click a little box and it'll start calculating for that, which is kind of a cool system. If you get a lot of squirrel middens, there's a place that you can measure your squirrel middens and put that into here. It also calculates your carbon and just catalog all your strata. It seems to be a useful tool. So one thing that we're doing with that FCCS is we put all that information in, and it gives us different fuel beds, and then we go back and map them. So this top map here in the upper left corner shows a pre-burn fuel map using the FCCS, and the bottom one is a post-burn using the same system. You can kind of see where it shows that orangish color is kind of a slash, has a heavy slash component where they went through and timbered off and left the tops there. In post-burn, we've gotten it back to just a TL6 or just a timber understory model. Then all the different grass components in there, all those things, it just shows gives us a nice idea of what we have before and after, but also it's just a good way to justify how you came up with the fuel bed you're using when you do your behaved runs, because sometimes that can be a little objective. The next component of that FCCS that we've been using is this page. It's their surface fire behavior potential. What this does is just kind of a 0 through 9 scale on the potential for the fuels to be to sustain fire. So it's got a surface one, which is the top number in the box there. Then it has a few subcategories on how that's derived. Then it's got a crown fire potential one, which is the middle box there, which shows a 5 there. And then the bottom one is the available fuel potential. So how much fuel would become involved with that. There again, it's a 0 to 9 scale. And what we've done with that on this next page is, I'm sorry, I'm going to back up just a little bit. Those 3 components comprise this FCCS fire potential code. So the top number is the 6, the middle number is the 5, and the bottom is the 3. So you can see that that's right there. So we take that number and we put it into this little chart here. And actually, we also assign these to those fuel beds in one of our mapping products that we do. So what you can show here is, especially with this crown fire potential, initiation potential, 0 through 9. So anything 5 and above, you know, is kind of worrisome as far as potential for crown fire. And so what we've been able to show is that we've, so in this fuel bed here, it's the openings for brittle. So that would be kind of a grass or sedge under timber. We've shown that we've been able to move it from a 6 down to a 4 through prescribed fire. So we've taken it from a number that's a little concerning to something under 5, which is much better. The next, and then you can see here for these other fuel beds like the pine oak, all those kinds of things. This one down here, the slash, that's up to a 7, so that's got a very high potential. We've moved it from a 7 down to a 4. So those are our numbers that, you know, just kind of represent how we're meeting that first objective as far as providing for firefighter and public safety, and then also the fuel loading one. So the last thing that we're going to cover is burn severity mapping. And what we've done here is taken data from USGS. They have the satellite imagery that they put out every couple months, and we just pull in the near infrared and the reflectivity layers, and we take the rasters from those, and we just kind of change the red, green, blue, those values, and then we produce a map like this up here in the upper left corner. And you can see here where this was a summer burn that had just happened before they flew that Landsat flight. These really stand out here. And then this was stuff that was burnt. These 2 units right here were burnt just maybe 2 or 3 months before that. So you can see where a little bit more severity down here in this southern half, and then up there, this is an opening within the burn unit, so that opening, of course, shows up as having more severity. But these were site prep burns, so they had been clear cut, and then we came back through and burned them in the middle of summer, and got really good results. We had been without rain for about 9 days, so that cleaned up really nice. So through that, we manipulating the red, green, blue, we get this map, and then what we can do is we can run that through a filter and float out the values, and then down here we can lay it back over maybe an IR or a ortho image, and then we can cartoon in that severity and add that kind of information, giving a map that we can use to measure severity. And then typically we'll follow up on the ground when we're out doing our plots and kind of give it the Park Service 1 through 5 scale as to burn severity, and just kind of ground truth that. Because with this, if anybody's ever done it, clouds, if there is clouds in the imagery, they can kind of skew that information. So that's why we kind of follow up with the ground truthing. That is what we have for our monitoring that we've conducted on this project so far. I'll open it up to any questions that people might have.
Yeah, for those that have questions, make sure you type them in the chat box. We'll give you a few minutes here. And Brian, I have one to start off.
Sure.
You started your monitoring program in 2004, is that correct?
Correct.
So what are some key things that you've changed in your prescription development or seasonality based on the monitoring?
Based on the monitoring, I talked about that day since last rain. We didn't know that going in, and that's one key thing. Also, just kind of with the red pine in the sandy soils. Day since last rain is a good one, but also, cloud cover can make a big difference. So say if we have an area that's got maybe a little more surface fuels, heavier fuels like slash, those kinds of things, just having cloud cover, which, I mean, it's kind of obvious, but that came out through some of those charts that we were creating, that just burning those heavier slash models on cloudy days with RHs above 35 at least for the first entry, seemed to make a huge difference as far as how much scorch we were getting in our canopy. So, I mean, we look pretty closely now at the condition of those surface fuels, and we pick our days based on which ones have the heavier fuels. We'll kind of try to shoot for those cloudy days, a little bit warmer RHs. We've had success with burning in the upper 20s for RH, which we had a lot of people say, you know, that you'll kill all the trees, you know, you won't be able to control your fire. But, you know, we've had some good burns on 28% days, 26% days, and had some good results. But there again, they had been conditioned already. They'd had one entry of fire. And I think having some of that char on the boles of the trees and raising that canopy base height, reducing some of that needle cast, all those components really help allow you to get bigger windows on your second, third entry.
All right. You mentioned the bowl char. Do you think has there been any thoughts like on the decreased merchantability because of that, or is your monitoring data basically showing that, you know, by year 7 after a burn, that's so reduced it doesn't matter?
Right. That's what I feel like we've been able to show with this, and that seems to be the big question. The other thing is we've talked to at least the local places here as far as people that take trees to the paper mill, and what they've told us is that as long as it's not a high-end paper, that little bit of char doesn't make any difference whatsoever. It's only when they get into the really high-end quality papers that they even look at that kind of stuff. But, I mean, in the South, everything they have has some kind of char on it, so.
That's correct. Okay. Another question, not up here, but that's come in, and this has to do with monitoring in general, but have you done, I'm sure you have with this, cost comparisons? So do you have like a rough, you know, number of plots per acre versus the cost per acre to do the in-depth monitoring that you're doing?
Yeah, so when I started, actually, we had questions, but we didn't have answers. And to be honest, I didn't really have I wouldn't say I wasn't sneaking out there doing these measurements, but I didn't really have my supervisor's permission to go do this. So I was working with somebody that had just come from the Park Service, and they had done the Brown's transects there. And we had just kind of gone out on days that we didn't have other projects going and started putting in these plots. And when the first information came back, then we seemed to really get the support. And as far as the cost goes, I think we might budget $1,000 a year to do monitoring, but I don't know what we have in terms of personnel hours or those kinds of things.
Okay. But, I mean, obviously, in your opinion, it's the monitoring's well worth the money invested for what you're getting out of it.
Yeah.
For adapting management.
Yep, with the monitoring and everything, we're still at about, you know, between $15 and $20 an acre to burn this project. So that's okay, including the monitoring. So, I mean, but yeah, I mean, if you don't have this stuff, there's potential that your program could get shut down. So, I mean, if you can demonstrate the fact that, you know, what you're doing is meeting objectives or it's not killing as many trees as they thought, then, I mean, that might save your program, which I don't know if you could put a price on that. So
that's a very good point.
Yeah.
So, we got a couple people typing. While they're typing, I got one more question, or actually a request, I guess. You mentioned you have a six-page protocol booklet that you've developed for this project?
Yes.
And is that something that could be made available so that we could put it as a PDF linking to this webinar recording?
Yeah, you bet. Like I said, it talks about archiving and some of that stuff, so I can clean up those components. So, you know, because people need to know that kind of stuff, but I'll leave those places for people they could type in their own, how they want to archive it. But yeah, like, I think that's a good idea. It'd be a great resource.
Yeah, I mean, it'd be at least a form that people can take a look at and, you know, get an idea and modify their own from it if they need be.
Yeah.
We have a question from Jim Bolden. He says he wonders if any type of historical conditions, data, or information are guiding tree density goals or any other goals in any way, or are goals primarily determined by future present fire hazard or risk.
Okay. So tree density, any type of historical condition data guiding tree density goals. So as far as the tree density goals, maybe they're getting at, are we trying to move more towards pre-settlement conditions maybe, or with that? Looks like he's typing again.
Yes.
As far, we did initially with this program bring out the pre-settlement. Right, exactly. Okay, so we did bring out the pre-settlement map of what was recorded as the conditions back then. And then they also, with land fire, they had that biophysical setting, which we used also. And so we, in some areas, we are trying to get back to that pre-settlement. And so we're honing in on those things like big blue stem, some of those indicator species that we know were here prior to the CCC covering the area in rows of red pine. So some areas we're creating those barrens, we're trying to move back towards that. Others within this landscape are designated for timber production. So there we have to maintain what they call a B-level stocking. So we have to have so many stems per acre to maintain that for timber production. All in all, I want to say within this project, we're supposed to have 10, no, that's across our, I'm sorry, across the Huron, I think we're supposed to have 20,000 acres of like pine barren pre-settlement condition type stuff. And just within this project, we've got 7,000 acres that we have through anthropogenic means and through burning, we've been able to kind of get it close to those conditions where the red pine isn't, it's not that monoculture, which my understanding it never was. It's always been found with other species. And we have that heavy warm season grass component, kind of open prairies mixing into to pine barrens. So yeah, parts, kind of a mix of everything within this project because it stems that 16,000 acres. We get a mix of just about everything.
Okay. So Jim's typing again. I got another question for you. So your photo points are linked to your Brown's transects, correct, and the other monitoring?
Yep.
Okay. So in your 6-page protocol booklet, does it also talk about the photo monitoring, and do you have links to the different online resources that you're using?
Yeah. They don't have links to the online resources, but in that book we did come up with some more stringent protocols about how far above, what direction, and kind of what percentage of the horizon are supposed to be shown in those photos to kind of give us hopefully better photo plots from here on out. But that's a good idea, linking that to that to the I have the books up here, but the national database for those the photo series. Is that what you're talking about?
Yes. Yep.
Yeah, that's a good idea. Linking that to the photo series. I'm writing that down.
And then, you mentioned a couple times the FCCS, and I put the link to that in the chat box. But are there any other quick and dirty online resources, that we should link to? We can put it as part of the archive that you found really useful to do this.
So with that FCCS, the cool thing about that is once you create a fuel bed, you can download a program called Consume, and they interface together. And then all you have to do is you just, when you open up Consume, it'll ask if you want to bring in something from FCCS. You bring in the fuel bed you created, and then it produces gives you a lot of your smoke information and your parts per million, those kinds of things, in a lot of carbon information. So I know smoke is always growing as a concern across the nation. That seems to be, if you're going to use FCCS, that consume is just a real quick and easy addition that you can add on there. And like I said, you do those runs once the fuel bed's created in less than a minute probably. So that seems to be handy. Trying to think, we use land fire a lot for mapping. But yeah, those are the main tools we've been using. Oh, and of course the USGS site where we get the Landsat data to do the burn severity stuff. Now, one thing, I don't have that information right in front of me, but our GIS person says that you can now make requests to, there again, I don't know who exactly, but they will do those burn severity maps for you per project. You can get those now as a product, probably from Boise.
Okay. So you're saying the USGS, Landsat, might be able to do the maps like that?
That's where we get the data from, but I don't think that they do the burn severity. Yeah, it's probably somebody, maybe GETA or somebody out of Boise that does the actual burn severity mapping that you can make a request to. I don't have that information, but that's what our GIS person was telling us. I'm sure with Google we could do a search for that. But yeah.
Okay.
That way, I mean, because it is kind of clunky to pull in that data and do it the way we're doing it. And if somebody is doing that for other folks, that would be a great resource.
Okay. Yeah, we can look into that too. Again, another question from Jim. Are you able to read it?
Oh,
right?
Yeah. Did the CCC primarily plant, yep, red pine on sandy soils, or was it more generalized on all soils? Yes, I do have a feel for that. They came through and pretty much just anything that didn't have trees on it got planted, regardless of soil type. And that's, I feel like we lost a lot of our prairies and probably pine savannas, oak savannas. We lost all those. They were probably there at the time, and the CCC just came through. Even though they hadn't been logged, they still planted them with red pine anyways. So, yeah, they didn't discriminate as to the soil type when that all got planted throughout here. It's just that most of our forest is on those xeric sandy outwash plains because nobody could farm it. That's why it ended up as a national forest, or at least that's my understanding.
Okay, it's good. I guess a comment to your previous answer. I know that on the Huron side, for sure, there's been development of different fuel breaks, basically removing the coniferous but leaving a lot of the oaks. And just my impression from having been on those or seeing those are really looking nice as far as oak savanna or oak barrens.
Yeah, and there's a couple things like, we're cluing into seasonality, and when we're not able to burn around our jack pine, that's the time to burn because that's when those warm season grasses really want to take off. So we're getting some, we go through and kind of create those through timber sales, and then we maintain them with fire, and we're getting some really good results from that. A lot of cool butterfly, dusted skipper, and some of those kinds of butterflies coming back. A lot of woodpeckers and yeah, some fun species that are coming back. I'm excited about some of that oak savanna stuff that we're creating as our fuel breaks.
That's good. Real good. All right. Well, it looks like, yeah, we there's a few more minutes for questions if anybody wants or has any last-minute questions, wants to type them in. Otherwise, we'll kind of wrap this up. So, again, I'd like to thank Brian and everyone online for joining us this afternoon. If you'd like to review this webinar, share it with someone that might be interested in it but was not able to see it today. I'm going to be getting a recording of the webinar up on the Lake States Fire Science Consortium website. That'll either be up later this afternoon or by tomorrow. For our next webinar, That's going to be on April 16th, 2015, 2 p.m. Eastern, 1 p.m. Central. We're going to have Trent Wickman. He's with the Air Resource Management part for the Eastern region for the National Forest and the Great Lakes. And he's going to be talking about easy-to-use smoke tools. And again, that link, webinar link is available on the Lake States Fire Science Consortium site. We'll also have that in newsletters and in announcement emails. So with that, I'd like to thank Brian again and everyone for participating today, and have a great rest of the day.